Hey guys, today we're going to talk about solutions. In the next set of videos, we're going to get into calculating concentrations of those solutions, but for now, I just want to talk about the chemical formulas and what we actually mix together to create a solution. So the first thing we have to define is what a solution is. And a long time ago, earlier in the year, we talked about a solution being a homogeneous mixture that contains two or more substances called the solvent or solute. The solute is the substance actually being dissolved, and the solvent is the substance doing the dissolving. So examples are salt and water. In this example, the salt is the solute because that is being dissolved, and the water is the solvent, which is doing the dissolving. Solids and liquids aren't the only things that we can be looking at. We can also use the example of gases to have the same idea. So if we have CO2 and general air or oxygen, CO2 is a solute, and when we exhale, we actually add that solute into the air around us, and the air is the solvent. It is doing the dissolving. The CO2 then mixes in with the air and ends up distributing evenly. So this doesn't just have to be solids and liquids. It can also be gases mixing together, etc. So remember, solute, the thing being dissolved, solvent, the thing doing the dissolving. And I always think of a solvent being a cleaner. Solvents tend to take oils off of mechanics in a car, so it breaks down that chemical compound. So solvents do the dissolving. Concentration of a solution is the measure of how much solute is dissolved in a specific amount of solvent. So the next video we're actually going to look at 3 different ways of solving for concentration, so we're going to be doing some math. So for the rest of this video, we're going to talk about the concentration, how we can affect it without doing any numbers. So we will end up calculating it eventually, just not quite yet. When it comes to solutions, there are a few more words that we need to know. The first one is solubility. And solubility is simply the ability to dissolve in a solvent. So whether that's sodium chloride or table salt dissolving in water, or carbon dioxide dissolving in air, it is the ability to dissolve. So for example, oil and water is not soluble. The oil will not dissolve in water, it will not disappear, it will always separate. In addition, there are 3 more definitions, and these are the classifications of concentration. You can be either unsaturated, which means you have something dissolved, but it's not very much. You can be 100% saturated, which means you have exactly as much that you can dissolved within it, or you can be supersaturated. So for example, if I take a cup of water and I add a teaspoon of salt, I'm going to then stir that water until the salt completely dissolves. If I add another teaspoon and continue to stir, eventually all the salt will dissolve and just a little couple flecks might be floating around at the bottom of the container. Unsaturated is the single teaspoon or maybe just 2 teaspoons. Once you have like that first little piece of salt that does not dissolve, that is when we're considered saturated. It is holding just enough or just as much as it possibly can. In order to become supersaturated, we actually have to physically increase the temperature of that substance. So in order to add extra salt to that water, we have to heat the water up to expand the molecules to be able to add extra stuff in there. So if you've ever made rock candy for a science class or a science experiment, you add sugar and you add sugar and you heat the water up and you add more sugar and it becomes a supersaturated solution. When the water is evaporated out of the container overnight, then the sugar crystals reform into a solid instead of being in the dissolved state. So unsaturated, there's a little bit of solute dissolved in the solvent. Saturated, it is holding exactly as much as it can. And supersaturated is we have heated the solution so it can hold extra. So ways that you can affect the concentration of a solution. When you create a solution, you can easily change the amount of solute that is being dissolved by changing the temperature of a solution. If you heat the solution, more solute dissolves. If you cool the solution, less solute dissolves. An example of this would end up being just general weather patterns. When you have air at higher temperatures, those molecules are moving a little bit faster, but they are also farther apart. So cool air, the molecules might be close together like this. Warmer air might be farther apart. So just the space difference between here and here allows there to be more stuff in those molecules. So this is what happens when we have high humidity days. It tends to be warmer days where there's a lot of moisture actually being held in between those air molecules. In addition, we have mountain ranges. One side of the mountain is always green and prospering, and the other side is always dry. That's because as the air travels up the mountainside, the air cools, and when it cools, it goes from this side to here. And as those particles get closer and closer together, it can't hold as much stuff anymore. So it ends up creating rain or precipitation, and then when the air goes down the other side of the mountain after it has lost all that extra moisture, it's now a dry, arid air, so it causes droughts on the opposite side of the mountain. So one side can be prospering and one side can be super dry. This works with other solutions also. If you're going to make iced tea out of a powder, you might use warm water out of the faucet in order to allow it to dissolve faster and then cool it in the fridge so you can drink it. So heat allows you to dissolve more stuff. Cooling the solution allows you to dissolve less. And there are a couple ways that we can describe concentrations. So in addition to the numerical value, the molarity or molality, we can describe a chemical reaction using the idea of the concentration of each of the substances. So for this chemical reaction, we have hydrogen and chlorine going into the reaction, and we're creating hydrochloric acid. So we can say that as time increases, our concentration of H2 and Cl2 decreases because it's creating something new that's going away. And as time increases, the concentration of HCl increases. So as this reaction goes on, the stuff on the left of the arrow is going away, which means the concentration is going down. The stuff on the right side of the arrow is being made, which means the concentration is going up. So if you see a chemical formula or a chemical reaction written, you should be able to tell that as time goes on, the stuff on the left or before the arrow is disappearing, and the stuff on the right is increasing in number. We're getting more of it. So that's just one way we can describe a chemical formula using concentrations. Additionally, we can adjust that chemical formula and how it reacts. So if we want to increase this reaction, if we want to make more stuff at the end, we can add more of either of the reactants. So we can either add more H2 or more Cl2. If we add more stuff in the beginning, we can make more stuff afterwards. In addition, we can add heat because, like I said, heat allows the molecules to move faster, which allows the reaction to happen at a quicker rate. In order to decrease the reaction, we're going to do the exact opposite. We're going to take away the stuff before the arrow, use less of it, or we're going to cool that reaction down. So keep in mind, I am not changing anything after the arrow. This is all to make the after the arrow stuff change. If I want more hydrochloric acid, I'm going to add reactants or add heat. If I want less hydrochloric acid, or I want it to happen at a slower rate, I remove reactant or remove heat. Now this is exactly how a refrigerator works. Refrigerators take energy away from the molecules. They go from moving very quickly to moving very slowly, and that slows the chemical reaction of the food actually spoiling. So this set of notes was an introductory look at solutions and concentrations and how we can describe or use concentrations. The next set of notes, we're actually going to start doing some math. So I'll see you tomorrow so we can talk about this and answer any questions that we might have, and then look a little bit further into the math aspect of it. See you then.